Welcome back to another episode of the Func Prog podcast with me, Christopher. And with me today, I have a special guest, Hécate. Welcome to the podcast, Hécate.
Thank you very much for having me.
Yes, you're welcome. Just for the audience members who aren't familiar with you, how would you describe yourself?
So I'm Hécate. I am a backend developer using Haskell in my day job. I am also a musician. I play the trombone, the bass, darbuka, and pindir. And I am also an archer, so I've been doing archery for a couple of years now.
Oh, really?
Yes. And so this has taken me some time in my weeks.
Okay, that's a great thing about having a podcast. You learn new things about people all the time. Just when you thought you knew someone. But can you tell me a little bit more about the archery thing?
Well, if you want to know everything. So I used to shoot Olympic style with a sight and counterweights. So it's the kind of stuff that you would see in Olympic shootings. And recently I moved to a more, I don't want to say more traditional, but basically just like shooting by the eye and not with a sight.
Okay. So the Olympic bows, they have all those attachments that you see. Those are counterweights and a sight as well.
Absolutely. And I switched to a more traditional way of shooting, where I can adjust my my arrows directly without having to fiddle with a sight. Because there's 3 or 4 moving parts in a sight to adjust horizontally and vertically.
Okay, so you have to fiddle with the...
Yeah, absolutely. Okay. And this was not really in accordance with what I wanted my experience, shooting arrows to be.
You wanted more of a Zen experience, is that...
maybe more intimate, more physical, with, where you can do some micro adjustments with how you take the string of the bow, kind of stuff. So I moved to that form. And I enjoyed quite a lot. I might start inter-club competitions next year.
Okay. And what got you into archery?
So I really did think to myself, that's a pretty cool sport. And I was 28 years old at that time. And there is a club in my city, and I just went there and registered. Really, nothing more than that. No deep thought about the nature of archery and the relationship between a person and its weapons. Just that's a pretty cool sport. I want to try it out. And
because the reason I asked was I've heard others say when it comes to archery. That it helps them stay in their body, so to speak, or if you work a lot with as a programmer, you spend a lot of time in your head, right? Mm-hmm. And practicing a sport, especially one that requires a lot of concentration, can be a way to empty your mind.
That's a very good thing to note. Yes, indeed. So when you're shooting an arrow, you have to simultaneously stay in your body, not being distracted, but you can't overthink things. You can't overthink because you have to let your muscle memory perform all the steps that you've learned during practice on how you bring the arrow up to your cheekbone, how your arms should move, how your back should take the brunt of the effort. And so it really is an exercise in not thinking too much and yet keeping focus.
Okay, so it's one of those things where if you start thinking about it, you won't be able to do it.
You have to perform a limited amount of thinking, I would say, to make sure that you do the steps in order, for example. but then you also have to trust yourself. You have to believe that all the things you've repeated during practice, they will come back.
Yeah, very, very interesting. But that's not why you're here today.
No, indeed.
No, so if we get back to the Haskell thing, one thing I wanted to ask you is or let me just launch right into it. Like, so at Scribe, you're using Haskell. It's not that many companies that use Haskell in production. But what would you say are some like pros and cons of using Haskell as your or using it in like a production context? Doesn't have to be like specific to the.
Yeah, so it's a very big question because I don't think using Haskell in itself unlocks magical powers. I think it very much is a tool, and the amount of investment you will put in it will also determine whether or not you have a good experience with it. I think for Haskell, and in the context of backend web development, you have to understand what's going on, when you acquire a database connection, for example. You have to understand the concept of a lock. You have to understand the concepts that are very much, common across every backend technology that exists. It's just that instead of giving you a very fast onboarding, like Rails promises to do, Haskell will require a bit more effort, but also will not betray you at the worst moment, like Rails actually does when you end up with like very big and complex systems that are very hard to debug ultimately. And so I think there is less a promise of a magic toolkit using, for example, Servant for serving web APIs. But also I found it more reliable because the expectations don't change radically between the moment you start the adoption and 10 years down the line.
Okay. So basically you're saying that it's there might be a bit of a learning curve or an adoption curve, if you will, but after that there are like no or fewer like nasty surprises. Is that? Yeah. Fundamentally, that's my point. I mean, of course, you get a lot of benefits from the static type system, for example, from the culture that puts some value in correctness. But also, I think it would be wrong to see Haskell as a magic bullet, because there are many skills as a backend developer that are transferable between technologies. I think a lot of our outages at Scribe, for example, have been due to problems related to how we use the database, how we perform locks, how we acquire, lock on documents, and how this, brings the system to a halt because we were not very careful with how we handle these the primitives of the database, how we use indexes. So ultimately, Haskell is very nice for backend web development, and the fact that most of our trouble stems from the database and how we use it is actually a positive point. Because I guess there's there's really no getting away from that, I guess there's always a way. You could like model everything using like TLA plus or something like Quint, which I talked about in a previous episode. But still, it's like that everyone will have that problem, I guess. Yeah. There are simply some things you can't model, whether with TLA plus, Agda, Lean, or even Haskell. Ultimately, sending software to production. You have to handle what's happening once it's in production. Yeah. I mean, if your server starts, if your server burns up, for example, Haskell isn't gonna help you there. It's like, it's a same problem for everyone.
Absolutely. And also you have to understand like what it's like to run a binary in a virtual machine or an operating system. Why there is like a space leak, why like file descriptors are being used, that kind of stuff. I know it's not a very beautiful way of talking about Haskell in production, but ultimately, as a backend developer, I love the fact that Haskell is most helpful to me when programming, and not so visible to me once it's in production.
Okay, so it's like once the program is done, you can sort of, or once you've written your program, you don't really have to think about it that much.
I get to think about the rest. Which means like HTTP connections, connection to the database, to the cache, to how systems interact with each other. Doing Haskell does not take like all of my time when programming and deploying, and for that I guess I am grateful.
Yeah,
because then I would have I couldn't just handle the fact that the language is requiring me all the time, and I would need to babysit it.
Yeah. So I was thinking I want to try something different this podcast episode as well. So I actually compiled a list of like common objections against using Haskell in production.
Nice.
And I thought I'm going to run them by you one by one, and then you can say if you either agree or you disagree.
Mm-hmm.
Okay, are you ready?
Let's go.
So, okay. So number one, and I think this is one of the most common ones, is that it's hard to find Haskell developers. Do you agree or disagree?
Well, that's a trick question, because it's like at which cost, like what kind of like, do you want to totally outsource your programming effort to some company and never have to think about it? Then I guess it is harder. I guess in the industry ecosystem right now, it's more tailored towards in-house teams. You would be hard-pressed to find a company that... I guess it's possible. You can hire Twig or Well-Typed, but you can't easily hire 20 people to do your Haskell programming in an outsourced manner.
Yeah. I guess you sort of mentioned almost an exhaustive list of all the Haskell Haskell consulting companies.
Well, there are a couple more, of course.
Yeah, but that's true. It's not like .NET or anything like that, where you can sort of find absolutely. Like, I don't know, just throw a rock somewhere and you will hit the .NET developer pretty much.
Yeah, and I guess you can take a plane to New Zealand, for example, throw a rock, and like a huge portion of their industrial fabric in programming is geared towards Microsoft technologies.
Yeah. It doesn't have that like big of a the ecosystem. I guess is not that big. It doesn't have as much like.
Well, I would say maybe it's the commercial incentives to be like a Microsoft MVP or whatever. The money is flowing differently.
Yeah.
So of course the industrial fabric is going to be different.
Yeah. But what about like recruitment?
So I was that's very funny. So I systematically recommended people when my workplace opened open roles for backend Haskellers. And there are always people looking for jobs in Haskell. Interestingly enough, you don't always have to be like a veteran of the industry to get your first job in Haskell.
Yeah.
We've had, math teachers, nuclear physics PhDs,
Okay.
People who've been working, with other technologies that approach Haskell. A friend of mine is an Elm developer and picked up Haskell as well as Elm at Scribe. So I think of course in an industrial context. I think you can get a job in Haskell. It's just that it's not magical, as in you don't escape the fact that recruiters or hiring managers are going to look for some specific profiles, some specific education, technical tests, and they may not even be in Haskell, but they will look for certain patterns amongst candidates. So it's not the level of Java of finding some JavaScript gig, of course, but I think it is possible.
Yeah. So do you have any advice for someone who would want to work with Haskell in have that as their day job?
Any advice? You have to be okay with remote work. And I guess that's also an advice for people who are hiring or looking to hire prospective Haskell. You have to be okay with remote work. I was very lucky that my first Haskell job was in Paris.
Okay. At what company was that?
A company called Fretlink, which has gone under, unfortunately. And it was freight logistics.
Okay.
Very interesting subject. But a lot of people are remote Haskell workers, and you have to be somewhat okay with that. Or move in one of the hubs of functional programming that exist. I know some of them in Europe, like Utrecht, for example, where you have Channable and Codify, Göteborg in Sweden, of course.
Yeah. A Carbon Cloud and
and even Scribe. We have maybe 5-6 people there. And Poland also, big hub. And Czech Republic as well, big hub of functional programming. Central Europe is getting some traction.
Really nice that's where it's happened. I mean, Poland, there's a lot of Scala there as well.
Of course. Elixir, of course.
Yeah,
well.
Elixir
feels like it's is also
coming
it's also very nice in that regard.
Yeah.
Good concentration of Haskellers in Brno.
Okay, so advice number 1: move to Poland.
Or be okay to work from home. And then I would say advice number 2 is to have visible contributions in projects on GitHub or whatever, because in the absence of easy jobs to build your CV, you will have to build your open source contributions so that your work is visible. And that's how I did it personally. I made sure that my contributions were visible and that I could back up my claims about my skills with concrete code.
It's I guess circling back to one thing that you said, it's I guess a good thing about wanting to work with Haskell in the industry is that I guess employees are not that picky with work experience if you manage to circumvent unless you said, there's always a risk that you end up with some HR person that's just looking to tick the right boxes.
Yes, the 10 years of experience on a 5-year-old technology.
Yes. Of course. Things like that. That's surprisingly common, unfortunately, I would say. But
I would also say something is that you don't need to be a wizard. You don't need to be a Haskell wizard in order to have a back-end development job. And I speak specifically for that because that's my profession. But if you know the domain of back-end development, because back-end development is not how can I put this? It's not a closed loop. You have to interact with a bunch of systems, and that's the main the main reason
of
a backend system. You have to interact with database, cache, file system, storage, object storage, and there are principles of like connection pools, locks, and HTTP connections, API design,
durability concerns.
Yeah, absolutely. Architecture. These are very transferable skills, and you don't have to be. Of course, if you're going to try and get hired for like a tooling and performance team, you have to know your way around the garbage collector. The qualities of strict the data and mutable data types in Haskell, like mvars, channels, transactional variables. But ultimately, if you want to do backend development, you have to be knowledgeable, or you have to want to learn more about the practice of backend development, which is thankfully usually general, in that, whether or not, if you access the PostgreSQL database from Haskell, from Python, from, God forbid, PHP, some principles will remain the same. In the performance characteristics of database, you can't really try and apply the functional programming principles to an SQL database. For example, did you know that
category theory won't help you?
Absolutely not, and nor should it, because it's a system in itself that has its own constraints. For example, you should know that Postgres does not like updates.
Yeah,
it's not as efficient as an insert. And so if you're going to like perform a lot of like sequential updates on a record, it's much more efficient to do them at once during insertion, because an update is actually a deletion and a creation of a row. And then, you're going to leave a lot of like dead tuples that are going to pollute the storage until the vacuuming of Postgres starts up. So that's why I love to hang around, people of the Postgres community, for example. I'm a bit involved in one of the local events in Paris.
Oh, okay.
And this certainly helped me get a more holistic vision of the systems I'm interacting with. So yeah, I think Haskell, maybe the job description says Haskell backend developer. You're going to deal with API users, with a Redis instance, with Postgres, with file system perhaps, with the concept of like a delayed recurring job queue. A lot of stuff happens, around architecture, and it's nicer to program in Haskell, but it doesn't prevent you from producing very bad architecture.
Yeah, yeah, that's a good point. I guess that's where those transferable skills
absolutely
come in. But yeah, I mean, that's I think that's also a very good point. The fact that when you're building web APIs, there's a lot of I/O, and Haskell is just your application server is just a spoke in a pretty big wheel.
Yeah, absolutely, and that's the various different kinds of I/O. It's these very different ways of interacting with the outside that make effect systems very interesting. But I guess we will talk about that a bit later.
That's later on the agenda. But okay, so the first point, I guess, yes and no. It can be hard to find Haskell developers, but it doesn't have to be a big problem, I guess.
I guess you have to become more flexible in how you recruit people, and of course, that's true for every employer that uses a niche technology. And because I guess if you're not NASA or like a very big bank, you can't like sponsor people from a foreign country to get a work visa and work on some COBOL or Haskell code bases. So if you can't really have the means of your ambitions, you have to become more flexible as well.
Yeah. Or Krakow is a very nice city. I'm just saying.
It's a lovely city. Yeah. And Brno and Krakow, very beautiful cities.
Yes, it's a very nice place. But okay, so moving on, number 2, and we can touch on this already. Like Haskell has a big barrier to entry, or a high barrier to entry. I mean, is that true or false? You would say.
Historically, it's true. Historically, it's true because we have started addressing this problem, but also because the barrier used to be very low if you were part of a certain population of, academics, researchers, people very interested in lazy evaluation and strictly typed programming languages. So in this regard, it used to have a low barrier to entry for people who were already in a very specific field. And by switching which population we want to target, of course, we realized that the barrier was very much higher for these people, me included, by the way. Like I've been very involved in documentation because I am like notoriously stupid and I need good documentation so that I may do my job. And also enjoy things more generally. So I'm very much aware that the barrier, it used to be higher and it's getting lower, but we are not yet at a point where there is no more work to do and we can like disband any documentation team effort. Like the job is not done. I would tend to believe that the job will never be done because otherwise, like a dead, like something that doesn't move is dead. Fundamentally, even trees grow very
shark that stops swimming.
Yeah, and even trees grow very slowly, but they still grow, and there is sap running around them, in them. So yes, I believe the barrier will always be too high for some people and appropriately low for others, and it will be a matter of priorities. Do we want to prioritize researchers, compiler engineers? PhD students, programmers, in which case, what kind of programmers, with which background. So yeah, I certainly sympathize with people who feel like the barrier is too high. I would, however, say a nuance that the barrier is getting lower by the day. Sometimes it's just about, editing a wiki page on the Haskell wiki to like modernize it, which I've done a couple of times recently. Based on direct feedback from people on a Discord server. So I guess the more we are listening to people, especially newcomers, the better we'll be able to take the turn of the century or adapt to new, if not new trends, at least new populations, new demographics.
Yeah, new people coming into the ecosystem.
Absolutely.
I don't think I've ever asked you, like, how did you get into Haskell in the first place?
That's a very good question. So I was around 18 years old. I must have been around 18 years old, and one of my friends that I had met on IRC at the time told me, hey, we're using Erlang at work to replace like a Ruby monolith, and it's wonderful. The 10,000 connections problem just vanished. No need for toolkits like Celery and such. It's so beautiful. And then a couple of months after, I was told about Elixir.
Oh, okay, yeah.
Like Ruby-like syntax, macros, but the power of the Erlang virtual machine underneath. And then, so I was writing little servers, little API servers, and it was just after high school. I thought to myself, well, now I'm writing servers. I'd like to write clients, like to send JSON payloads from a terminal, and have binaries. I wonder what kind of languages are available to me to reach that. And so I had to pick between Rust, Go, OCaml, and Haskell. So I tried Rust, and it cared too much about stuff that it didn't want to think about, like especially memory management. Because I was coming from Erlang, where the garbage collector is very efficient, and I didn't really have to think about that.
Yeah, but so you sort of got into Erlang a little bit.
Yeah, of course. Yeah. Erlang and Elixir were the first programming languages in which I was writing bigger programs. And before that, it was Bash. Before that, I was not a developer, but a systems administrator. That was my hobby.
Okay.
And then, Go, I tried .Go. It felt a bit insulting. It felt degrading, I'll be honest. I was doing Elixir and Erlang before, so like functional programming, recursion, that kind of stuff. So yeah, I wasn't having a great time with Go. I mean, things could get done, but that wasn't the point for me. I wasn't like desperately looking for a job. OCaml at the time when I tried it, the tooling was awful. The tooling was very, very hard to take. And also, the package management story especially was very confusing. There were like several tools, competing tools, and there were no clear choice, and each of them were not that great. I heard it has gotten better now, and I don't exclude using OCaml in the future for some stuff. And Haskell, yeah, so I went into it. And actually, Haskell was very promising because I was not at all studying mathematics or computer science in higher education. I was studying economics and business administration. So this was the language that promised me a lot of learning of higher mathematical concepts like abstract algebra.
Okay. Yeah.
Applied to
it's
programming.
Like a strong mathematical foundation underneath.
As with Erlang, it promised me to teach me, more things and more interesting things than just, writing one line of code after the other. So I stuck with it, and the Haskell book, Haskell Programming from First Principles, had been published around that time, and it definitely was very helpful for me. That was really the book that unlocked my understanding, my practical understanding of Haskell.
Is that something you would still recommend for people getting started?
Yes, as well as the books by typeclasses.com, from Julie Moronuki and Chris Martin. Yes. Sorry, there are too many Chris's in this community. But yes, Chris and Julie, very good writers, and I love their books. Finding Success and Failure in Haskell. Also, a very good book about like the practice of monads through the maybe monad, the either monad, chaining computations and doing error recovery and handling. So yeah.
Okay, so if you start with Haskell from First Principles, you can move on to those other books.
Yeah, absolutely.
Later. Yeah, I'll put links to those in the show notes. Okay, but so getting back to your Haskell, the start of your Haskell journey, you found Haskell, and you did you take to it immediately or like?
So good question. So I was still more productive with Elixir at that time. So I went after 2 years of preparatory classes, which is a very French thing after high school, I went into business school. I had a burnout, and the year after I had to find a job. So my first job was like a part-time Elixir programming job in Paris. But still, most of the data modeling that I was doing was through Haskell type declarations. So I would be opening a file, writing data types in Haskell, and like typed transforms between these types. And I would be implementing them in Elixir, and write my code in Elixir. And at some point, this very strange state of things started, getting to me. And at some point, I thought to myself, well, I could just, skip the middleman and write all these things in Haskell and learn how to be productive in Haskell for writing web APIs and web services.
That's very interesting. So you were kind of like using Haskell as kind of like a proof assistant on the side.
Well, I wouldn't dare call it like that, but definitely
very lightweight proof assistant.
No, because I also do that for like well, I don't need proofs. It's just data modeling tool. So, and it's a very powerful tool. The power of a Haskell type declaration is immense when you are doing stuff in Python or Elixir, because it clarifies so many things, and restricts also the ways how things can go wrong, and forces you to clarify things about the kind of data that your functions take. Because fun fact, when you use one of the type checker extensions on Python, lists have only one type. And actually that's like a very huge restriction on what lists in Python can have. Because a list in Python can have many types, or like many elements of many types. But when you start applying type signatures, there can only be one type. That type can be abstract, of course, can be like a polymorphic type, but there can be only one. It's not a tuple. And same with Elixir, there are like a lot of guards on functions where you can ensure the type of an argument that is passed, and thus do some form of dynamic dispatch on if you pass a string, an int, an atom, and even like what is the shape of the atom. But yeah, writing things in Haskell data types from the get-go helps remove a lot of confusion, of initial confusion. Like you're forced to be very precise in how your arguments are handled, what kind of arguments. So yeah. But of course, there was some tension between me being very proficient in Elixir at the time, with all the toolkit, especially it's the tooling, right? Like the language is one thing, but it's how you master the available tools to build your products. And so I guess, yeah, it did take some effort to become a beginner again in Haskell.
Yeah, and starting over.
Yeah, and be humble, about, okay, I don't know, what to use, what are the best practices, I should like ask around, I should ask stupid questions. And that got me into documentation because I had been fed the beautiful documentation culture of Elixir. And the joy of programming and the idea that you should have a smile on your face when you're programming this language. So yeah, that got me into wanting the same thing for Haskell, and getting my hands in the engine and trying to take more responsibilities with writing docs for Base, for example. Helping out with Haddock, because I'm of the opinion that if the tooling is bad, this will not motivate people to write better documentation.
So because Haskell has kind of like a bit of a different documentation culture, I guess.
Yeah, and
it's like, here is the type.
I guess.
What else do you need?
And also it's also a culture of where you take your foundational understanding of things. For example, like applicative. Like if we take the applicative functor documentation, it is described, I believe, as a lax monoidal functor, or something like that.
Okay. Of course.
Which makes absolutely zero sense if you haven't read any papers, or if you're not even remotely interested in the properties of lax functors.
It's almost like that joke, that like what is a monad? Oh, it's just a
monoid in the category of the functors, which is also like a very trivial thing because everything is monoid when you're talking about categories. But yeah, it's the overloading of jargon that is like kilometers away from your own concerns. I wanted to make command line tools. So yeah, but you know what? I think it's also very good to have like new pair of eyes on things, and as I was talking about, like new demographics being taken into account when we design interfaces and abstractions.
Because I think that hits the nail on the head, because like to one person that description of a functor might make perfect sense, because it's like, they know the jargon, they recognize the terms, and they like, they don't want they might not want like a, how can I, like more of a like user's guide. They just want to know like, okay, what is this thing? Like, okay, yeah, it's that. Like, but if someone is coming into Haskell from like as more of a programmer, like a practical mind, like, they want to know like, how do I use this? Like, what is it good for? Like,
yeah, absolutely. And you can't even say that it's a wrong definition, because yes, technically it is a strong lax monoidal functor. It has like laws and operations that are well understood, well researched, well proved. So you can't even say it's a bad thing to write. It's just that the way it is, being promoted, like at the very first sentence of the control.applicative module talks about that. And also, it was, it has been brought after, in the hierarchy or like functors, applicative monads. It used to be like that functors would be the superclass of monads. There were no applicative in the beginning, so it was retrofitted. So it was like a huge research work to ensure that the mathematical correctness of these abstractions would hold. But it also is interesting to showcase that applicative functors, or functors that are like sensibly more powerful than just functors, bare functors, and also don't require sequentiality, the sequentiality of monads. So you can, in theory, have some operations being done concurrently, because they don't rely on the previous result. And that's a nice thing, like you can populate a record in Haskell through I/O, but with the applicative instance of I/O, so that all the fields are populated in a way that is not sequential.
And I guess it makes sense for like, input validation, for example, or parsing, and a lot of other things.
Well, for input validation, I have a favorite library that is yet another type of of functor. It's the selective applicative functor, and the library called validation-selective is, in my opinion, a very, very good example of something that has that has come from research. There's a paper that was presented in the Rehack about selective functors, but the documentation itself is so good. Like, there is a huge table in the module documentation that says like all the operations of like semi-group, applicative, alternative, and selective, and how they operate on success and failure, how they compose. All the instances are very well documented with lots of examples. So you can have something that is like very rooted in research, and like with like strong mathematical properties, because we need those ultimately. It's like about the trust you put in software. It starts with how well defined and well understood the primitives are, and then you have to know your audience, and the audience is sometimes people who just want to validate input of forms, like web forms.
So what is an like what did you call it, like a selective functor or applicative?
So
selective
a selective functor is a type class. Fundamentally, it's a type class, an interface that has applicative as a superclass. So it is lodged right between applicative and monad. It is not the only thing that could be there, but it strikes some kind of middle. So you can have a functor where, for example, if you have a function called select and you give it an either, if you pass it a left, you must apply a function that you provide as well. And if you give it a right, you may skip that function and the effects of that function, and simply return the value contained in the right constructor. So either the type has a left and right as opposed to result, which has like a sum and no, it's success and error, I think, in other languages like Rust.
Yeah, or like it depends, I guess. Like, you know, in OCaml, it's what is it? It's like error and OK, I think.
Yeah. Well, yes, absolutely. In Rust, they use OK. So you've got this micro step towards computing stuff from a previous result, which is the sequentiality that we found in monads. But you can also skip that altogether. And this gives you more nuance and more precision in how you trigger some effects and some functions, and so how you trigger validation of input.
Okay, so for example, you could use that if you get the left, or like what's called an error in other languages, you could use that, add like an error accumulating function, for example, if you want to return all of the validation errors at once. Is that sort of the point?
That's a very good question. So the accumulation of errors is actually, well, yes, you would accumulate these, and then if you have a success, you would perform an action, like a parsing, for example, or something else, like another transformation. And ultimately, the validation-selective library gives you a bunch of instances of type classes, including selective, but also alternatives and such. So you can always pick like the best validation methods for your needs.
Okay.
And it's also well documented, a bunch of examples. You don't even need to understand. Like I tried to read the selective applicative paper a lot of times, and it didn't really, tick in my head. That wasn't really the kind of stuff I appreciated to read. And then I came on this library and understood in context, in practice, what this meant. And then everything was unlocked.
Okay. So you sort of, when you approached it from the other way around, like starting from like practice, then you could
but
understand
like from a very manual perspective of handling an object and seeing like a Rubik's Cube, for example. You can learn about the theory of how to resolve a Rubik's Cube, like with such and such complexity and time, and the theory of the colors and such. But when you get the object in your hands and you rotate it around, you get a very, another feeling, like a more instinctive understanding of the object. And so that's the same thing for me and abstractions. If I can use them first, it's going to improve much more my understanding of their theoretical foundations.
Yeah, I think that's really interesting, because I think this is quite a common thing. Sometimes I think that, because I've like I have a friend who, I remember when we were studying for like math exams, he basically he read the textbook like from the the relevant chapters, and then he was pretty much done. Like then he could go in and ace the exam. And I never worked like that. I needed to to understand something. I really needed to really break out pen and paper, solve a bunch of problems, and get them wrong a bunch of times, consult the answer sheet or whatever, and then that's how you do it. That's I don't know, sometimes it feels like you have to have something, like you said with the Rubik's Cube, you have to have it in your hands before you can put it in your head, sort of.
Yeah, absolutely. And even the most abstract of topics, if they want to attract a larger population, they need to have some grounding in something that other people can can touch and feel. Like category theory, for example, always presented as very abstract, very in the clouds. But the main application fields of category theory are abstract algebra and topology, and these are the two main ways through which people understand and have their daily practice of category theory. But I don't think it's very rare to need to handle something in order to better understand it, because it's making uses of our senses, and especially like the sense of touch. You need to understand like how things react when you touch them, and like any baby will be desperate to touch anything and put everything in their mouth, because also taste is a very, very important sense.
It's I guess that it's harder with code, but I mean, you can sort of do the same thing with the program. Like you can sort of prod it and then watch how it breaks and then sort of try to repair it.
Like how you understand time is also important. I can show you like a complexity, like a algorithmic complexity of a program, but you may not have a very good feeling for it until you've had to wait like 1 hour or 10 seconds, because it's a much more efficient program. And even then, usually the kind of big O complexity forgets the constant part of the complexity as a whole of a program. So sometimes there are like very, very inefficient programs on paper, but the constant is so small that it doesn't matter.
I guess like type inference is a classic example where like or maybe no, that's actually a bad example because it can be quite slow. But
for example, you can have something that on paper is very quick, but if you have like 10,000 instances of it, then it becomes very slow.
I guess like I don't know, with the .NET and the JVM startup time, for example, so like throws a pretty big constant right in your face, like, so then it doesn't matter that much how fast your program is.
And if you have a CLI tool, of course it's going to be very unnerving, to have the VM startup time. But if you have a server that restarts, every once a day, once a week, that is it really that much of a problem?
Yeah, no, that's a good point. It's like it depends how large of a factor. It's like the like how big is the constant factor, like compared to the like actual complexity part of the equation. But I think something else that was interesting was that, like when we were talking about category theory, etc. I think one thing people often ask, like, or let me rephrase it. Like a lot of people that I have talked to who are used to, like, I don't know, they have been programming for a long time, and then you start to talk to them about Haskell, functional programming, etc. And they don't really see the like utility of thinking about programming as math. And I didn't really understand, like I could understand this on a theoretical level before, but it wasn't until I started actually working with typed functional programming languages that I sort of realized how useful it can be to be able to reason about your program in terms of math, basically. And I guess that's another example of things where it's sort of hard to get it if you just think about it in the abstract. But if you actually play around with like statically typed functional programming, then you sort of start to see that, well, it's actually useful to be able to think of things in terms of like categories, etc. Because it's like, I mean, they're just another tool for abstraction, pretty much.
So it's a very good way of thinking. And I would also like to very specifically define what we mean by abstraction, because sometimes it's just about, it's understood to be, it's abstract, like the details are muddied and also the way it operates is blurred. But there is like a quote that is often attributed to Dijkstra that says the purpose of abstraction is not to be vague, but to create a new semantic level in which one can be absolutely precise. Maybe it's a apocryphal quote, But the deal is, when you make abstractions, it's to make clearer some other specific parts of the business logic, for example, and to make it very robust. But at the same time, we don't use these tools, and we should not use these tools of mathematical formalism the way that building engineers, for example, use the laws of physics. Like, for example, the many laws of physics that building engineers rely on every day, like the density of air, the gravity, like the density of materials. Building a road is something, you have like a degradation of the road when trucks roll over it. It's understood, but we can't really view network as a road, because in network, for example, sometimes the fibers can be cut, the packets can be lost. You don't see anyone disappearing in their car on the road. But
that would be very strange.
After but sometimes the packets can be lost and have to be resent. So I guess one of the very few like physical laws that we have in computing is the speed of light.
Yeah, that's a hard physical constraint.
Yeah, and then you have to orient everything around it, and when you stop doing so, you become very disconnected about how things will run. Then you go more towards mathematics, I guess, than informatics. But also, I think so. It's nice to have these formalisms at the core of your system, especially for business logic. But also, I believe you must be prepared for things to go immensely wrong in all the ways. Like your file system might have a crash, your database index may be corrupted. So there are many things. So you mostly can't rely on much when you're doing software programming, because it will go wrong in all the ways. Like every little bit of software that we rely on, starting with the kernel, can go wrong in some way. And then it's up to you as an architect how you're going to handle these problems, and how you are going to make the most of a bad situation. For example, Linus Torvalds from the Linux kernel is very much against some patterns of early crash in the kernel.
Okay.
Because the reasoning is, how are people going to submit a bug report, if they can't even use their computer?
Yeah, that's a good point. It's better to try to repair it and then have the crashes happen in user land.
you run dmessage on Linux, get the logs, send email, or open a bug on bug tracker, and just like that, the experience is much better. It's like, please call your phone provider if you don't have phone reception anymore.
Yeah.
What the hell?
Yeah, I mean that obviously doesn't work.
So I guess the thing with formalism, lovely thing, and I love using the rigidity and the solidity that is given to me by Haskell for some things, and then inevitably when it's a matter of sending stuff to production, I have to look to other cultures. I have to look towards Erlang, for example, where you've got people who are used to dealing with trash fires at huge scale. But because what? Because why? Because if Ericsson's systems fail, then you've got entire populations who do not have access to phone service anymore. And you can't have researchers on Svalbard, for example, having their phone cut because null pointer exception? That's bullshit excuse. You're going to end up in tribunal for that.
Yeah. No, it should not crash, or
or if rather it's going to crash, how do you recover from that and make the most of that, and how do you keep service running?
Yeah, that's a whole another podcast episode in and of itself.
Yeah, absolutely.
I think, because it's
we could spend hours discussing it, and we will. No, I'm joking.
Yeah. But it's that the classic Erlang thing of let it crash. I mean, a lot of people think, oh, how can you build systems that way? That sounds really crazy. But like you said, it's more of accepting the reality that crashes will happen.
Absolutely,
and
yes.
Better embrace that fact and get good at dealing with it rather than trying to sort of avoid it at any cost.
But you would be surprised how many people do not want to think about that and only want to focus on the happy path, because usually it's what's being paid for. Like when you're paid to build a system, you build to deliver features, and rarely those features include recover from wrong input, recover from such and such partner is having issues. These all have to be thought of as second thoughts. Like it's always like an if and not a when.
Yeah.
And for me, I think it's very important to approach things with a very pessimistic, mindset, or maybe not pessimistic, but just keep in mind that things will go wrong at some point, because things always go wrong. And that's why we try to deploy things on like Kubernetes, Docker, with like self-replication, auto balancing, and a bunch of strategies to make sure that when a pod explodes because of any kind of problem, other instances can take the load. So yeah, but in a way, maybe it's a kind of formalism. Like you have to formalize the fact that things are awful.
Yeah. Yeah, but I guess this also goes back to that, if you bring up TLA plus and things like that again in the discussion, there are ways that you can actually, if you look at the system from the outside, you can formalize this and write up a verifiable specification, etc. But back to your point, I think the main problem isn't that we don't have the tools, is that people don't even want to think about the unhappy path.
Absolutely, because oftentimes it's not what you're being paid to do, and also people don't, higher management doesn't want to hear about the bad things. Oftentimes it's like, oh, we'll see about that when we arrive. We'll have a recovery plan when our data center catches fire. No, we should have that from the beginning. Data centers do catch fire. In France, a data center from OVH in Strasbourg caught fire. It was located right next to the Rhine River. How ironic is that?
Yeah.
If I would tell you the data center right next to the river is going to catch fire, you would laugh at me. But it did happen, and when the CEO of OVH tweeted, "Now it's time to activate your emergency recovery plan," a lot of people replied to him saying, "The what now?"
Yeah, what plan again?
Yeah, the thing you activate when things literally catch fire.
I guess a lot of people don't really. I guess we saw that with when there was this huge CrowdStrike incident, for example.
For instance, yeah.
Yeah, I mean, what's the plan in case all the data gets corrupted and lost, and I guess in many cases it's that exact thing. There isn't any.
Yeah, I mean, sometimes you think you're too big to fail, or that nothing ever happens, but yeah, no, things can happen, and they will. It's just a matter of when, and it's okay. I mean, you can't live in perpetual anxiety all the time. You also have to know that for some threat model, you are prepared, and yeah.
Yeah, but I guess this is the how security exploits are born as well. People. It's very easy to forget the fact that what if someone else is in control of the system, or someone whose interests are not aligned with mine, for example.
Yeah, absolutely. No, there are lots of ways to think about that.
Yeah. I mean, I think that's possibly a third podcast episode, how systems can go wrong and what can be made to what can be done to prevent it.
Yeah.
I just wanted to run one more Haskell objection by you. See what you think. Another common one is that the library ecosystem is too small.
So that's a very vague objection.
But let's say, if we take something like Ruby, for example, has a very extensive, like Ruby, Node, etc. They have very extensive. Python, I guess, is the quintessential example.
So I guess you can have two factors in that. I mean, there are probably more, but I'd like to raise two factors. The first one is that you can't simply register an account on Hackage on the package repository. We've had problems with spam and copyrighted content in the past, so now you have to send an email to say, "Hey, I'd like an account, please."
Okay, so you have to sort of be let into the...
Yeah, and you have also the choice, the option to be endorsed by other people. So if you know people in the community, you can send them a link to endorse your account, and then you will be granted uploader privilege. That's also, of course, related to the fact that there is no moderator team that is active 24/7. As opposed to NPM, for example. So there's that. And also, I guess there are less SDKs, software development kits, that are directly produced and maintained by SaaS companies. Like if you go on Ruby Gems, for example, a lot of the uploaded packages and maintained packages are SDKs for APIs.
Okay, so it's a wrapper on the REST API, for example.
And oftentimes these are maintained by the companies. Like Tencent has a lot of wrappers uploaded on Ruby Gems for their cloud solutions. And these days, if you want adoption of your API, you have to provide SDKs for Python, Node, and Ruby. And so you've got less of that in Haskell, of course. You've got a couple. However, it would be lying if I told you there were no SDKs, no first-party SDKs on Hackage or even available, but certainly less of them. So yeah.
But I guess it also depends quite a bit on what you're trying to do.
And also the population, of course, because if we take, for example, starting 2015, we've seen more and more packages oriented towards backend web development. So, but there were packages before that. So who were these packages targeting? It was a different population, different demographic. A lot of people were putting out proofs of concepts on Hackage.
Yeah, some not really artifacts mature things.
Or artifacts of published papers. And then, if we have, for example, a huge boom in data processing and data analysis in Haskell, we will see more and more packages filling that niche, for example. So yeah, I guess it's mostly who were Haskellers at which point in time.
Yeah.
And for the past 10 years, it's more and more backend developers because the language has been de-risked for adoption. I think we're going to, whereas as opposed to Ruby, for example, where Ruby on Rails caught a lot, but a huge portion of the population of Rubyists. So of course, you will see a lot of API wrappers and stuff for Active Directory, for example.
Things like that.
Yeah. So we used to have a lot of academics in Haskell, and the packages used to reflect that. I mean, I guess if you're an academic in functional programming or lambda calculus and type theory, you will find lots of good stuff on Hackage.
Yeah.
And we're starting to see lots of good stuff for backend web developers too. But for data analysis, it's still very, very sparse.
I guess if you're like a compiler engineer and you're hearing me talk about like lack of packages, you're probably like, what is he talking about?
Yeah, absolutely.
It's crazy.
Like 10,000 parsing libraries, like bindings for LVM, that kind of stuff.
What else could you need? No, I don't know. I also grew up in the Erlang ecosystem, which is not famous for its like great variety of packages either.
Well, it's used to, but now that it's like integrated with Elixir's HexPM, it's wonderful. Like you've got a lot of Erlang packages, and even the documentation of Erlang stuff has moved on to Hex. So new population, new outlook on life. Like I don't know if you saw, but like Erlang distributions don't ship out man pages for modules anymore.
Okay.
Like you could be able to you were able to run Erl-man and like module function, and that would like open a man page in your terminal. But no, like the culture has shifted towards the product of what's it called, hexdoc, xdoc. Some the static site generator, like Hadox, to view documentation in HTML.
Okay. Yeah. I mean that's like big improvement, I would say. I haven't hacked Erlang in quite a long time, and I know that it's gotten a lot better. Like last time I touched it, or when I started, I think Rebar version 3 was still quite new. So
Rebar, wow. But Rebar 3, beautiful piece of toolkit, yeah.
Yeah, I know, it was very good. Speaking of which, you also, related to package managers, you also have the Flora project, right?
Yeah, it's something that is indeed in which I'm also involved. But
what is Flora?
I'm involved in many things. So Flora is a meta package index. So it's a very scary word. But basically Flora, the purpose of Flora is to index all of the packages of the Haskell ecosystem under and serve them for the users in a way that is more pleasing. It's very lowly goal of being more pleasing to the eye, but also indexing more of the Haskell ecosystem. So it is a meta-index. Why? Because it takes data from indexes like Hackage, but also like much more specific indexes that you may not know about, like the Cardano package ecosystem. IOG, the company behind the Cardano toolchain, self-hosts a package index called CHAP, the Cardano Haskell packages. And so these are included in the dataset of Flora in a way that makes you able to see where these packages are located in the wider ecosystem, what they depend on, and what packages are depending on them. So, for example, if you are a maintainer or library on Hackage, and you go to Hackage, to package page, and you see the reverse dependencies, you can see which packages on the Hackage depend on your library. If you go on Flora, you can see which packages on Hackage and in the Cardano ecosystems.
Okay.
So from IOG and also from MLabs, which is a consultancy company that has its own package set, which is also being indexed on Flora. So yeah, the idea is to give you a more holistic, view of the ecosystem, and also to innovate. And I guess that's the nice thing about Flora. It's not critical infrastructure yet, so we can innovate and offer some new stuff, but also fail and fail miserably at that.
Like we said before, that's a essential part of learning.
Absolutely.
Yeah.
And one of the great things about Flora is that the code base is also kept in such a state so that people can quickly understand what's going on. Because a lot of contributions in Flora have been made by people, through pair programming. Okay.
So they have sort of come in through sort of an apprenticeship, I guess you could.
Well, it's like a couple of sessions.
Yeah.
But it's as simple as having a call on Discord, for example. Someone shares their screen, and then we add some new things, or we fix a bug. But yeah, so that's very important. You must be able to onboard people on a code base very easily. So you have to stick to a couple of things, like the principle of list astonishment, which is something
that's a good one. I like that one.
Yeah. So, and you've got communities based around that, like for example in the FreeBSD community, decisions about the architecture and the changes are mostly driven by this principle of list astonishment, because when you are handling a production system and things start to go wrong, you do not have time or the mental budget for innovation. There is an innovation budget that you have to spend very sparingly ultimately, because when things go wrong, people have to be able to fall back into like known patterns and ways of doing things that they fully understand to restore the system to working state.
So I guess by analogy, I guess Hackage is the BSD in this case, and Flora is maybe something more like Linux distro?
Simultaneously, no, it's not, because Hackage decided not to... So Hackage is a thing that I like to say. Hackage is a web application made by people who fundamentally despise the web. So it doesn't use a relational database engine. It uses something like that is called acid state, which is an in-memory, in-process database that aims to replicate the acid properties of a database engine, which means that it is totally incompatible with everything you may have seen before. So when you dump the data on disk, it's like the custom binary format of acid state.
Okay.
So there is no tooling to view this data at rest and operate on it, because you can only operate on it in the process of the server. Everything you may learn elsewhere about database engines, the complexity of operations, the cost of some stuff, how to administrate the database engines, is absolutely useless in this context. You can't have multiple instances of the same Hackage, service running concurrently, because acid state runs in process. So the index cache, basically the index, is loaded in one process.
Yeah, on a single machine, I guess.
So you can't use it as a synchronization point for data like you would use Postgres or MySQL. So yes, in this case, I would say the principle of list astonishment has been violated. Because
I was quite astonished.
People from the outside who would expect a widely used technology and get help rapidly. You have to onboard them on the very specific and custom setup that there is.
I see. So Flora is more like
Flora, it's backed by PostgreSQL. API uses servant, JSON, no custom formats. It returns HTML, like a good old PHP or Ruby on Rails application. Limited JavaScript. I want this software to be easily maintainable, easily understood, and that it can be operated easily by people other than me. And I think that's very important, because I want Flora to be adopted by private teams, by companies, for example, for their private needs. And this has to replace Hackage in this context. And so the application itself has to be a good citizen of people's existing architectures. So, for example, at one point I may ask some help on how to write a Helm chart, something to integrate the application in a Kubernetes setup.
Yeah, and then it's like, but it does help if it's just vanilla. It
does, because
Postgres.
if you're like infrastructure engineer today, one of your main requirements when deploying something is how well does it integrate in our existing Kubernetes setup.
Yeah. So that does make a lot of sense.
So I think ultimately empathy for others is one of the main motivations when I do things.
Yeah.
A lot of empathy, and that's something that you can find in a lot of my other open source work. For example, I've been involved in the creation of the Haskell cryptography group, not to pioneer new and exciting ways of doing cryptography, but on the contrary, to de-risk the adoption of Haskell by providing an infrastructure, an administrative infrastructure for cryptography packages. Because it's one thing to provide new algorithms, but who do you reach out to when there is security issues? When there's like a vulnerability that's like plaguing a lot of people. So it's a group that is affiliated to the Haskell Foundation, and so the bindings provided. So we don't like re-implement cryptography; that would be crazy. But we provide bindings to libsodium, to Botan, to OpenSSL. We provide a home for packages so that they don't fall into disuse, and thus like vulnerabilities never get addressed. I guess like one of the repositories of this GitHub organization is about the governance of the whole group. It's like how we take care of packages, how like we are like here to like submit like patches and metadata revision hackage, if needed.
Yeah, because you want to be able to trust the people you get your cryptography from.
Absolutely. You can prove the cryptography all you want, but if it's fallen into disrepair, it's completely useless.
Yeah.
It's at best it's like a nice historical artifact. Oh yeah, this used to be the best, the fastest, and the most powerful MD5 implementation back in the 2000s. Do not use MD5.
Yeah. I mean, it's always a moving target, right? And
absolutely.
You need to keep up.
And I think sending an image of how can I put this? Sending to people the image that things are well taken care of. That there are people who take care not only of the technological aspect but also of the human aspect is also very important. For example, I'm involved in the Effectful effect system, not in a way that involves the lower level considerations, interpretation of effects, but the website. There is a whole website of the ecosystem that I've been maintaining, and where I'm categorizing effects for like web development, data storage, network operations, like systems programming. And it's very useful ultimately. People may think that it's a luxury or it's vanity, but if you are going to invest in something like an effect system, you want to be able to easily know what's available to you, what's missing, and find examples of other effects that have been written if you need to write your own.
I guess that's a lesson that we as programmers have to learn over and over again. I think we usually over-index on like the merits of a technology and under-index on the marketing.
Yeah, and I think having a product vision of what you do is also very important. And you don't have to always do that. Some practice of programming is meant as a hobby, is meant as art, is meant for the pure joy of it. And it would be, I think, futile to try and prevent people from doing so. And you will see people who are like absolutely against using LLMs, for example, for coding, because it takes away some of the joys that they have from the act of programming.
Yeah,
but
the craftsmanship.
Absolutely. But if you're going to put something publicly that is designed for other people to be used, you need also to have empathy. And I think that I'm going to come back to empathy a lot. But good documentation, good marketing, not false advertising, but putting yourself in the shoes of people who are looking to adopt your product. I think it's very important.
Yeah. Yeah, I think it reminds me a lot about the are you familiar with Seth Godin?
I can't say I am.
Yeah, but he's a marketing. He's written a lot about marketing, but he usually plays on the he usually talks a lot about empathy and things like that, and that marketing. I think marketing has kind of a bad reputation. People think of some kind of sleazy Wall Street, Wolf of Wall Street dude who's basically just ripping people off. But like you said, marketing can also be an act of empathy. I think if you have something some software project or something that you genuinely think can help someone, if you if you don't say anything about your product, you won't be able to reach or help that person. So marketing, I guess what I'm trying to say is marketing can be an act of empathy, even though a lot of people usually view it as sort of a selfish thing.
Well, maybe. And also, there are a lot of people who are also frustrated that some anti-patterns are still being, done in their ecosystems. And when you ask them, well, what do you recommend instead? They will tell you, well, I made this library 10 years ago. Just use it. And actually, it's a library nobody ever heard about, because the person who wrote that library considered the problem solved because it fixed the technical problem, but did not fix the social problem of adoption.
Yeah, that's very good.
So that's why we have nice places like the forum, for example, where people can advertise what they've been doing. The simple fact of the simple action of publishing an announcement report. It's massively useful. And I try to motivate people online, on social media, and tell them you should post that on the forum. And then people will tell me, well, but what if I'm being criticized, or what if I've got bad feedback? And I try to reassure them that it's part of life ultimately.
Yeah,
it's the cycle of life. And so I'm less fond of marketing, but more fond of the product approach to things. So it's what problem do you intend to solve, for whom? Before ever coding, what problem do you solve, for whom? Where are you going to advertise this solution? How are you going to stay in touch with the users? What kind of input are you going to take? How? In which circumstances? That's definitely something that I care a lot about.
Thinking through the entire software
absolutely
life cycle.
The life cycle of the software, which begins before the software is written, and ends approximately either when it reaches critical mass and nothing much has to move, or when you find out that it can be deprecated in favor of something better. So in Haskell, functions that we write, int to int, for example, addition or multiplication, they ensure that you don't perform what we call side effects. Side effects, it's a very subjective denomination for network, file system operations, mutable state, global mutable state. And basically the things that can change between two calls of a function with the same parameters. So if you call the addition operator with 1 and 2, you're going to get 3 all the time. Nothing is going to change. You're going to change some registers in the CPU, but it's not going to affect the state of the world outside. And you may think it's actually very basic, but in Java, for example, in the Java platform, the equals method of the URL object performs name resolution, performs DNS resolution, so a network operation that is blocking. So if you want to compare for equality two URL objects, you're going, like the Java virtual machine is going to try and perform a network operation that is blocking.
Yeah, that's a very fascinating.
That is crazy. That's just crazy. And so this gives a very nice property for compilers, because if a function is pure, you can expand its definition at call sites. So instead of performing a function call, you can use the definition of the function directly. And for humans, it means that software has just gotten much more predictable. Then you have I/O. So I/O, the whole deal with I/O is to say, this will do things outside. This will perform some tracing. This will get some data from the cache. This will ship logs to your logging infrastructure. This will get some stuff from the database. This will throw an exception. And so, yeah, that's a nice way of categorizing some functions as being, if you want, poisoned by the interactions with the outside world.
Yeah, like,
there's a problem
these
with
are
that.
impure functions.
Yeah, but there's a problem with that, because not all of these functions mean the same things. Not all of these operations, operate under the same constraints, and you have a case of semantic opacity, where every possible interaction with the outside world becomes bundled in the same basket. It's I/O, and you pretty much give up on what it could do. So effective systems are here to label operations. So you used to have the I/O type of label on functions that would do very different things. And now you will have much more specific labels. And these labels are like entirely user-defined. You have like the trace effect, the cache effect, the log effect, the DB effect. They don't have the same runtime characteristics. And as such, they can be easily separated, because they mean different things, not just for the computer and the compiler, but for you, the programmer, who has just graduated from a programmer to an architect. So you don't like pour concrete, on a work site anymore. You have to understand, what kind of concrete is best for what kind of tension, of pressure. So yeah, the deal is you get much more visibility on the interactions of your systems with the outside world.
Okay, so just to clarify, like, instead of having just one type, that is I/O, that sort of represents everything that can like sort of have an effect outside the program itself, you have discrete types, like you said, like maybe a cache, or some type that sort of represents that, like, this function will or needs a cache backend, or this will write a log, etc.
And more specifically, it's discrete labels on a type. So you used to have a type like I/O of int, for example, like get an integer from the outside world, whatever it may be. And now you will have a type. So I/O is replaced by EFF. So it's a monad, but it's a type that not only has the value in its signature, but also a type level list of labels, of effects. And so
okay.
And so instead of I/O int, you may have the F monad with the label, the effect console. So you get that from the console input.
Okay, so that's how like Effectful manages the like the different effects, is a type level list.
And there is also a very nice trick that it uses to piggyback on the constraints syntax of Haskell. So when you have polymorphism in Haskell, you can have like a return type of A, and this A can be constrained on several things, on several interfaces or type classes, like num, so it has like addition and multiplication, or eq, so it can be compared against another item of the same type, and the effect list can be polymorphic, and we can just mention the effects that are like immediately being used. So the trace effect, for example, can have a trace constraint on the effect list. It doesn't have to be all of the effects that you're going to be using in the whole of your application, which is pretty cool because GHC can tell you when a constraint is unused. So if during a refactoring, GHC starts telling you, oh, well, the log constraint that you had here is now unneeded, then you can think to yourself, was that like something that I wanted? Is it like an accident? Or is this something that I really like don't care about because it was really unneeded at that point?
Okay, so GHC will watch you back for mistakes and like also maybe help you clean up stuff.
Absolutely. So yeah, there's like like integration layer, if you would, between these higher concepts of effects and the constraint system of GHC, where GHC can tell you, well, this is unneeded or this is needed, and then automated tooling can also insert those constraints for you, which is very useful.
Okay. Yeah. So let's say I have a function that wants to log something to the console, for example. Then the return type of that effect will be, or let's say it just logs that. It logs to the console and then returns like a unit. So what would the return type of that function be?
So it's going to be f, es, and es being a type variable, and unit. And es will have a constraint on the, well, it depends how you want to put it. It can be the console effect that is provided natively by Effectful, or it can be a log effect. And this log effect, you can have multiple interpretation for it. So you can have an interpretation that sends the logs to Elasticsearch, another that sends log to the disk, or another one that sends the log to the console.
Okay, so two questions. So the first one is like, okay, so and the constraint means that like in this type level list of effects, like you mentioned, there has to be a logging effect. Is that?
Yeah, and so the functions that use that function in return will also need this log effect.
Yeah, I mean this is quite similar to how the like algebraic effect system, or like yeah.
It is an algebraic effect system.
Yeah. So I was thinking about like how the Coca language, for example, and things like that.
But for Coca is even better because it's directly integrated in the compiler. So the ergonomics are very different, much better, you could say, in some aspects.
Yeah, but it's like I mean they designed that in from the beginning. It's
absolutely can't really compare that
exactly. Like you can't really call it cheating, but it's like
but it's like comparing like the type system of Haskell and type system of something like MyPy or Sorbet for Python and Ruby. It was like bolted on after the fact.
Yeah, after the fact.
As an afterthought. So yeah.
So, but okay. So, but my second question would be like, how, or can you use this to like swap out the logger during testing, for example?
That is absolutely what we do at work. Of course, you don't want to have to run an Elasticsearch instance in your local dev setup.
Preferably not.
Yeah, that would be nice. You want to send directly everything. Well, not directly, actually. There is something very cool that we do, is that we send all the log statements in a mutable data type during the tests. And if the test fails, then we dump the logs of the test.
So that's nice.
Yeah, so usually you would like, hide all output or show everything. And in our case, we have a very... I wouldn't call it a hack, but it is very smart, where you redirect everything to like an mvar, for example, and then if there is a test that fails, you will dump the output of that test. So integrated with the log library.
Yeah, that sounds really smart. Because, like, I mean, that's a common problem that I have. Is like, when you, I mean, naturally when you run the tests, most of the time you want to like sort of like just throw everything away that gets sent to like standard out or whatever.
Yeah.
But like you said, if a test fails, the logs are usually very helpful in helping you like
absolutely
understand what went wrong, because it can be like, depending on the complexity of the test, there can be a lot of different things going on.
And that's why I think it's also very nice to have a structured log library that doesn't simply send stuff on standard output, but gives you some hooks in how the logs are processed, and then you can decide what you want to do with them.
Yeah, no, I agree. It's sort of like what do you call it? Like table stakes. When you have a big distributed systems, you usually want
even when you
sinks and
don't
stuff.
have big distributed systems, like these days, I only swear by structured logs. Even for like monoliths where you have like one instance of a server that runs. For CLI tools, it's different because the console is the user interface.
Yeah.
But yeah, no. For web services these days, no, I wouldn't want to use anything other than. So it's funny because at Scribe we have a lot of open source libraries that we use directly in our products. So the Logbase library is the one that I use for all my logging needs.
Okay. I was going to ask as well, like, what do you use for testing?
Tasty.
Okay.
Yeah, Tasty HUnit for unit test, Tasty Golden for golden tests, all the adapters for quick check, for property testing. No, Tasty. So it's a harness. It's a test library that has plugin system, and then there are plugins for each type of tests that exist. There's a benchmark also, Tasty Bench.
Oh, okay.
That exists. I think that's the name of it. But
we'll
put the links in the description of the episode.
I'm just how can I say, journeyman hobbyist Haskell programmer. So,
but that's something that I wrote in one of the pages of the Haskell wiki called "How to Write a Haskell Program." It was terribly outdated, and so I rewrote most of it, and especially mentioned like every. So it used to be a bit abstract and not very in touch with how we write Haskell these days. And so I rewrote some parts, especially how to test your software with all the kind of libraries that you can use under the same banner of the Tasty test framework.
Oh, nice. We'll have to make sure to link to that. Because that's another thing that's really good for people who want to get started with something, like just some... Because I think that's one of the things that is kind of annoying when it's like you said before, like when you start over in a new ecosystem and you're like a complete beginner, sometimes you feel like really lost, like you don't even know how to structure your project, or like how do I test things, how do I run things, etc. So I guess those resources are really, really helpful, I think.
Absolutely, yeah. And once again, we are back to the concept of empathy. And if you have empathy for others, this will, drive how you make software, how you publicize this software, how you promote it and present it to others, how you take feedback, how you interact with the community of users. And ultimately, it will have, a correlation, maybe not causation, but like strong correlation with the impact and the positive impact that your software has on people.
Yeah, because like you said before as well, I mean, it's sometimes you forget that software is like a social activity.
Absolutely,
like software development.
Absolutely. The writing of software these days is much more social done before, thanks to like all the video conference systems. But like pair programming and mob programming, for example, super useful. Twitch streaming, even that, just like streaming yourself, programming is much more common. And using software, like asking a community for solutions to problems. Interacting with the maintainer of a piece of software, like opening a pull request on GitHub for all to see and not just like via email exchange.
Yeah, I mean it's changed feels like we went from like vendors selling stuff at tech conferences, and that's how like software would spread, and now it's like the Primogen streaming on Twitch.
For better or for worse, but absolutely, yeah. And you can't really deny that evolution of the space. And yeah, you used to receive software by mail.
Discs or like
or floppy disks and
shrink wrap software.
Absolutely. And now it's a Git clone or apt install.
Exactly. Just like npm install. You have the whole internet on your hard drive. Okay, so a slight digression there. But I was wondering as well, like, okay, so when you have this effect type, like, okay, so you have a function, it returns an effect, and what happens next? Like, how is that resolved, so to speak?
So you've written your functions with the effect type, but the main function of your Haskell program still wants a computation that is of type IO of A. So you have your tracing, your logging, your caching, your database. What do now? So you you're going to execute those effects, which is done through functions that are usually called run-db or run cache, which take a computation that has the effect and returns you the computation without the effect. So because you need to provide some information for your effects. For example, the address and the port of your cache system, if you use Redis, or of the authentication credentials for the database. So you're going to run these functions on your functions. So you're going to chain these handlers. We call them handlers on your functions. It's done once, usually, because your programs usually have one entry point. And then you end up with an IO type. And then, since that's what the main function wants, that's what the compiler wants, then you're done. I gave a talk at MuniHack last year and this year at Lambda Days about this very thing. And the slides are online, and the video of MuniHack is also online. It's called Effect Systems in Practice.
We'll put that link in the episode as well. I was wondering as well, like, there are a bunch of new effect systems cropping up now. Bluefin is one that I've heard of. Like, how does Effectful compare to...
that's a very good question.
To Bluefin, for example.
So, indeed, it's a very new effect system that I haven't seen used in the wild yet. But the theoretical thing is that it's very, very, very similar to Effectful. So basically, you've got two major types of effect systems around. You've got the ones that rely on this technique called free monad. So basically, you have a data type that emulates this interface that is called monad. So where you have like the ability to express an effectful computation and to compose two operations, and it is a data type, and basically you will build your program on top of that data type. So you will return the constructors of this data type, and it's very inefficient because unless you ask the compiler to perform all kinds of very expensive optimizations, especially at build time, the performance will be very bad because you basically have a program that has to run your program.
Yeah.
Like, it's not like you write 1 + 2 and this gets compiled to like assembly and like to native operations. You have to have an interpreter for a program that you've encoded as a data type, which we call defunctionalization, if I remember well. So basically, it's a layer of abstraction that is also a layer of indirection. And that is not great.
Yeah, because every like then I guess every effect sort of becomes sort of an optimization boundary.
And also, the computation becomes a data structure, which is, nice because you can, in theory, inspect it as well. Because instead of writing 1 + 2 and the plus being like directly mapped or like with some indirection but very little to the CPU's understanding of an addition, you have a data structure called like operation, which has a constructor called plus. And this has to be like evaluated by some Haskell code to then, what a CPU understands as to be an addition. But the performance trade-offs are usually like either you have like execution time that is quadratic and linear inspection, or you have the opposite. So linear time for execution and quadratic time for inspection. And so you've got like polysemy and free or simple, which are effect systems that run on free monads. And then you've got Effectful and Bluefin, and some others, which have basically they have the performance characteristics of having a record like a reader T, like a reader transformer, and I/O. So it's very close to I/O performance.
And the just so I understand, like the basic pattern of like this reader, because this was also like one of the first common effect system patterns, right? Like I remember there was some
one of the first crutches in the absence of a more like elaborate effect system would be to have like a reader T. So like a reader is a read-only value that you have throughout your program. And the T, it means that it's a transformer that you can compose with other monads, and the monad with which you compose it is I/O. So basically you've got unrestricted operations, except for like passing around configuration. And that was for a time the least difficult way of having some semblance of effects, or at least of application architecture. But that's not great because you still have the same problems of I/O. But at the time, it wasn't. Well, the ecosystem wasn't ready for anything more. The ergonomics weren't there simply. So,
and I guess the problem they were trying to solve was mostly like, okay, how can I swap out things when I test my code, right?
And I guess the problem was also how to be hassle-free, how to have a hassle-free experience when architecturing Haskell programs. Because then if you want to be able to swap things, like swap the implementations during tests, for example, then you have to have a much more, how would you say, like comprehensive transformer stack, where every possible effect is in fact its own transformer that you can interpret differently, should you want to. But if you don't need to, then a simple reader with your configuration and unrestricted I/O throughout your program is usually what people were going for.
I see. And I guess before that there was also like the MTL thing, where you sort of have everything as a stack of, like a big stack of monads.
So the big stack of monads is transformers, and what the MTL does, the monad transformers library, is that it provides you with constraints syntax for these transformers, but it's still the same transformers.
Right. Yeah.
And one of the problems with MTL is that if you had like 12 transformers, which may sound like absurd, but ultimately for like a monolith, you quickly reach that number. Then you would be using these 12 monads at each function call. And when you have like a do notation, each line is invisibly separated by the bind operator of your monad. And if you have 12 monads, you have 12 bind operators. And then you have to tell GHC, please over-optimize this at the cost of compilation time to make things disappear when they're not needed. And yeah, that's, MTL had its advantage over bare transformers, but kept some of the problems of transformers, especially how state and errors, the state transformer and the error transformer, the except transformer, interact with each other when there's an exception. So yeah, so Effectful, for example, in this effect system, you only pay for what you use. The performance is very low level because you are free to implement things internally with like arrays of primitive data types and unlifted data types, and really like really gnarly implementation details. And that's also something that Bluefin does. Also, although with Bluefin, you do call the handlers of your effects at the use site.
Ah, okay. So that's a difference.
That's a difference, and if you get a lot of effects, it can feel a lot instead of calling them in one place. But that's the main difference ultimately.
But so let's say.
I guess I'm wrong. It's the main technical difference, but also the main social difference is that the ecosystem is not the same. Like you will get much less choice of libraries, and because Effectful, the point of Effectful is also to replace your existing application architecture in a way that is very nice and seamless. Whereas Effectful requires of you to rewrite your effects.
So because Effectful was made to interoperate with different with
MTL and transformers, yes, absolutely, and that's why it has all the facilities and all the instances that MTL uses, or rather requires, to be a good citizen of an existing application. And also it has lots of bindings, lots of libraries to interface with existing libraries like logging, all the data storage stuff, network programming, file system, that kind of stuff.
Yeah, so it has a good interoperability story. I guess.
Yeah, that's the thing, and that's a design decision that prevents some stuff, but it was thought to be the thing that gets you the most value when you use it. It means that it's not like only for greenfield projects, but because as most new features are built upon older features. Like you got in proportion, you got really not that many greenfield projects because of the investment in tooling, in expertise, in understanding a system. You want to run things where you know and you understand how things will run. So the deal is to improve gradually the quality of software that already exists, without changing the expertise, without invalidating what we've learned about the system until now.
And they sort of stand on the shoulder of giants.
Yeah, and also improving the foundations. It's also that so and making gradually better foundations for new features. And which is hilarious because, for example, it is absolutely not my opinion when it comes to type checkers. I absolutely am not convinced at all by gradual type checkers.
Oh, okay. Yeah. Tell me more.
I just think that when it comes to correctness of types, gradual type checkers have yet to convince me that they are, delivering on their promise. And because usually they're bolted on languages that have a more liberal understanding of what a type is, what the type of an object is. And usually, when you have a gradual type checker, it has to restrict a lot the language on which it operates. But anyway, that's a tangent. So yeah, but for applications that already exist, I think it's a good thing that you are able to take a monolith that has been around for 10 years or so and gradually replace its parts with foundations that are simply better in terms of ergonomics, in terms of performance and predictability.
Okay, so I mean, and in this case, you could like sort of incrementally adopt Effectful, for example.
Yeah, absolutely. And you can also, replace the type signatures, for example. You can replace the execution function of your server, but you don't have to replace your code, because, for example, the bindings to the log-based library, they are not really replacing the function calls. They are because they are providing the instances that the log-based library expects of an MTL, transformer stack. You can keep your code. It's just that you're going to change the things around it. The type signature is going to move from one syntax to the other. But the majority of the code doesn't have to change.
Yeah, because and it's only in the resolution step or whatever, when you actually handle the effect, that it sort of comes into place.
Yeah, it handles a lot for you, especially the fact that you don't have to change code that already works.
Yeah, that's cool. And so I guess if you're starting a greenfield project now, and you want you expect it to grow into substantial size, then it would make sense to start with Effectful, or?
I will even do you one better. I've been starting greenfield projects. I don't expect them to reach substantial size, and I'm still using Effectful. It's just nice. The experience is just nicer.
Yeah, it's a good out-of-the-box default.
Absolutely. And, it has a very nice ecosystem that is thriving. We are getting new plugins, new bindings frequently. And people generally have a lovely time with it. And so I'm very happy to, also the creator is also very good at what he does and has a good user experience as one of the core principles of this system. And so for me, that's a huge selling point. But that's the same selling point that attracted a lot of people to Ruby and Elixir, is that people are being told, you will have a nice time using this software. And you will build things, and this will bring you joy.
Yeah. Yeah, you can be productive right out of the gate, this.
And it's also it's not necessarily about being productive, because you can start a project in Java 21 or something, or it's not about the very capitalistic notion of productivity. It's about also when things fail, the quality of the error messages, how they are orienting you towards resolution. If you are badly composing functions in a transformers setup, you will get two type signatures that are not matching, and if you have 12 stacked on top of each other's effects,
big type error.
Yeah, you have to find Waldo, where is Waldo, where are the two types that have been inverted. Whereas with Effectful, there is a good user ergonomics story to it, and it will tell you, because it is a little bit smart about itself, there is no handler for the state int effect, for example, that you're trying to invoke. You're trying to call the reader or whatever, or database call, but you haven't provided it to your functions context. Please do so. So the errors do not punish the user. And I think that's something that is really nice, because it's not about the initial adoption push. It's also how you deal with the system on a day-to-day basis for the next 10 years. And I think it's something that for which you see the limits of stuff like Ruby on Rails, for example, is that 10 years down the line, they become like hugely bloated, and the developer experience is not the same. Absolutely not the same. And that's why people, like a lot of people, move to Elixir and its Phoenix web framework when it was published, because it promised like the joy of a greenfield project that they had initially with Ruby.
Yeah.
But will it withstand the test of time? That's, another question.
Yeah.
And I think that's what I like with Haskell, is that, it usually does, because refactoring is also very nice.
Yeah, and I guess that goes back to like, the point why you would want effect systems and stuff like that as well. It's like, I guess one problem I always have with these like dynamically typed languages, or I guess rather like something, a degree of freedom that you have to be mindful of when you work in like dynamically typed languages, is that thing like the principle of least surprise or whatever. It's like it's very easy to accidentally make different parts of the system interact in unexpected ways, or things that
absolutely.
So I think like in a pathological case, you sort of have to understand a very large part of the code base to make changes to like a dynamic system. Whereas in I'm working a lot with F# right now. It's like I rarely need to understand anything beyond the function that I want to modify. Like, of course, you still have to understand the system at some level, but like you don't need to have like this super detailed understanding of like what comes after and what comes before the function you're actually changing if you have a very strong type system.
Absolutely.
That's my experience. And I guess effect systems are like a continuation of that, because it gives you even more control.
So that's a good insight indeed. And you need to understand the intent of the function that you are changing, and there's the stuff that the type system cannot encode. But mostly you can rely on the type system to enforce invariance of the system, and that's of the software system, and that's really good. Yeah.
So I guess maybe to wrap up, Effectful. Maybe maybe you could say that it tries to spark joy. Is that
that has been my experience with it?
Yeah.
And I'm committed to make sure that people who use it, have a reliable foundation for their applications.
Yeah, that sounds great. But yeah, now I think we're running out of time. I just want to ask you one final thing, and that's, or maybe two things. Like if someone wants to get into Haskell, like today, year 2025, what's a good starting point?
I think
you recommended the book already.
Yeah, so I would recommend Haskell from First Principle, Programming Haskell from First Principle. I would encourage you to join an online community, or a local one if you're lucky enough to have one. But that's also because asking people questions can easily steer you in the right direction, and confirm your biases, or ensure that you're not going in a rabbit hole for no reason. Because there is so much to discover and to master, and you might be tempted to think, oh, I must learn category theory and homotopy type theory in order to make like CLI tools in Haskell. No, you do not. Absolutely not. So I think it's not, but that's what I personally enjoy. It's the social aspect of learning. So that's what does the most for my learning. It's like when I'm with other people of different levels who can like help me out. And I still very much need some help on some stuff, even today. I've been programming in Haskell professionally since 2018. I will never stop learning, and that's beautiful, I think.
There's a lot. Haskell has a very high skill ceiling, I guess.
Yeah, and even the things that you interface with through Haskell, You know, like sometimes you do Haskell for Haskell, and sometimes you do Haskell for some things outside of it, like databases or whatnot. And I think it's beautiful. It's like it's itself a beautiful study subject and a beautiful tool to interface with the world. And I guess I would finish this interview by saying that you can't do functional programming if you're being bombed. You know, so yeah, if bombs are falling on your house, you can't do functional programming, and that sucks. But yeah, I guess, you know, with all that's happening in the world, in Ukraine and Palestine, I think it's important to remember that, you know, civilians are the first casualties of war, and war is not hell because there is no innocent in hell. So yeah, that's something that can reach you very quickly. You know, one day you may be under bombs, and that's something we should oppose.
Yeah. I mean, it's how can I say? Like, you know, we're living in a very uncertain world, and there's a lot of like terrible things going on.
Yeah, and you know, sometimes you see like the profile, the GitHub profile of some Haskellers, and you know, the main thing that is like displayed is, here is my like open source will. Like if I was to die because I've been like drafted in the Ukraine security forces, here are the people who are going to inherit my packages, and this like calls you back to reality in some way. Or, you know, like people like Russians who have been in exile to avoid, you know, being part of the conflict. So yeah, this has a real concrete impact on people. And so yeah, you can do functional programming, you can do like study of types, you can do all the nice little hobbies and all the study of computing if you're getting bombed to hell. We're
privileged to be able to just, you know, sit here with and talk about like functional programming without having to worry about.
But even if you've got a Swedish employer, like I know my employer had to like be very careful of like what happens if the Russians are trying to like launch a cyber attack, because my employer is in Sweden. So, and imagine if you're working in Finland, like, oh, you might see the Russian troops one day, you know, across the border, or like in the Baltics, where like you've got boats, you know, like dragging their anchors on the, you know, on the oceanic floor to cut cables, or just, you know, like in Palestine, you get bombed to hell, or you get like settlers like shooting you. So yeah, no, it's horrible, and I think, you know, we should not like lose our humanity when we're trying to relate to other people. And again, principle of empathy.
Exactly.
But I think it's my very Catholic upbringing that you know. Gives me that sense how I approach the world.
Yeah. Let's I don't know. Let's hope for a better and brighter future. Last question: where can people find you if they want to sort of contact you?
So I used to be on Twitter, formerly X. I'm not anymore. I'm not active there. On Mastodon, you may follow me, although I'm not that. I'm less of a social media figure these days. And the functional programming Discord server, also I will be there. So reach out. And the Discord, the Haskell forum, the Matrix channels of the Haskell community, and of course GitHub.
And the Haskell discourse is really good, and I can also recommend the functional programming Discord, because there's a lot of things. Well, it's a channel for every language, pretty much.
Absolutely. And even for job seekers.
Yeah. I mean, believe it or not, there are jobs in functional programming, as we have heard here on this podcast. But yeah, with that, I guess it's time to end. Thank you so much for coming on the podcast.
Thank you for the invitation. I'm very honored to be here.
Yes. Okay, I'll see you later. Maybe catch you in Krakow.
Oh, Krakow as well. Yeah, definitely. Right.
Yes. Bye.